Right now, more than ever, we need very good engineers to pinpoint all the incorrect things, all the faults, all the errors that are coming from AI generated code. Because having a very simple prototype is easy. Like, yes, AI can do that. A cloud code can now like create like a very simple prototype of something, but debugging that, finding it ready for scaling, making it ready for all the edge cases, making it secure for all the attacks, etc. For these, we need like better than ever engineers.
Welcome to the Feria Cast, where we bring all things science, engineering, technology, and innovation. Today, we are joined by Dr. Ilke Demir, a scientist inventing the future of AI, from detecting deepfakes with our fake capture technology to synthesizing virtual worlds for volumetric filmmaking. With a PhD in computer science from Purdue and stints at Facebook and Pixar, Dr. Demir bridges cutting-edge research with real-world applications, all while advocating for women in STEM. So it's nice to have you on the show.
Thank you for the invitation. Great to be here.
Yeah, so we'll dive in. So could you tell us how you got involved in STEM related fields? I see your career spans computer engineering and even electrical engineering, and you have a PhD in computer science. Could you give us the background story of it?
Absolutely. So even when I was a little kid, I was really amazed by electronic circuits. You know, we used to do these surgeries on um, house items, like, you know, like looking at opening and looking at the radio, looking in the telephone, etc. Then in my high school, I got selected to represent my high school in a math olympiad and computer science olympiad, and for that you need to know coding. So in high school, our seniors, not our teachers or classes, etc., like our seniors 2 years older than us, actually started to teach us coding, and that's how I got really, really interested. Oh, I can make computers do what I want. um, so from there, I actually started. I did my undergrad in Middle East Technical University, which is the best university in Turkey, in computer engineering with a minor in electrical engineering. And that opened my path to even more curiosities to follow, like for robotics, computer vision, uh, not just making computers do what I want, but also all the electronic things to do what I want. So that's basically my journey.
That's an interesting journey. So, Ms. Demir, in your PhD, you worked on proceduralization. That sounds like a very, 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 very technical word for me, personally. So, could you tell us what that means?
Of course. So, since 1960s, 70s, there were actually generative models in a different sense, not the deep generative models that we are using right now, but generative models in the sense that they are based on some grammars, based on some procedural rules. You can actually create any kind of data you want. It's like a simple, if you want to do a 3D model of a little house, it goes to the whole house model goes to floors, 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 right? So you can actually
Yeah.
represent this as a rule that house goes to single floors and the roof, right? Then in a single floor, you can say, okay, I want wall, window, wall, window, wall, window. So that's another rule, etc. So all of these are actually called procedural modeling, procedural systems, and proceduralization is if I give you the whole building, can we extract these single rules in a hierarchical way? So that's proceduralization. Having a some data. It can be an image, it can be a point cloud, it can be 3D data. Getting that data and extracting the procedural representation, which is, it can be a context-free grammar, it can be an S system, it can be just a set of rules that represents that 3D data, basically. Then what happens if you have that procedure, right? Like what if you have the grammar of a building? Then it's like language. From that grammar, you can make many sentences, which means from that grammar, you can make many derivations, which goes to many different buildings. You make a building with 3 floors, 4 floors, 5 floors, whatever. You make a building that one floor has windows, one floor doesn't have windows, etc. So you can use mix and match all of these grammar rules to make sentences, and that is like how you use the output of proceduralization, which is the procedural model, to create much more diverse data.
Hmm. So proceduralization can turn complex 3D models into generative rules, yeah?
Absolutely, such a beautiful summary. Thank you.
Okay, so I'd like to know, how does this challenge traditional engineering approaches or workflows?
That's a great question. So, the modelers, animators, and everyone that is working in the 3D industry may be making games, may be making movies, may be Pixar or EA games or whatever you want to, your favorite studio, so your favorite 3D studio. They have been using these traditional 3D workflows for so long for procedural modeling, for the forward parts. So they write very detailed grammars, they write very detailed rules, and then they create these beautiful buildings, beautiful, let's say, worlds, 3D worlds from those grammars. But then you need to have this domain knowledge, how to actually write represent the whole world with some grammars, right? When you have proceduralization, you can actually have one of your old movies or one of your old buildings, one of your old cars, whatever, and then extract the rules from them, and then tweak the rules if you want to, tweak the grammar if you want to edit it for the new one, or take the grammar as is, but stylize it in a different way so that it's like actually different from the previous world, but still you are creating so much vast amount of data based on the grammar. So traditional workflows can use the inverse path to extract the grammar from an existing data and then plug it into the forward path so that they can create much more diverse data.
Hmm. Interesting. So I'd like to move to a different topic. Deepfakes, yeah. Deepfakes, the buzzword, the scary word, deepfake. Yeah, so deepfakes are emerging. I'd like to know, how should we react to this? I mean, should we be worried? Should we be excited? Should we be scared? I mean, what's your thought on this?
That's a great question. For example, I have been wondering because the light on your face is changing in your video. I'm like, is he really real? You know?
Oh wow, I could be artificial intelligence or something generated.
Well, it's always possible. So
Hmm,
that's how everyone online should react to everything that they see online. Is
okay.
it real? Is it fake? What is this person trying to make me do? Basically, that's like, if they everyone needs to, when they are watching something, what is the intent? Because you may not see, because now the generative models, actually, like video models are even getting much better in quality, in photorealism. So it may be the case that we can never look at it and understand it just by the visual artifacts, but think about the intent. Is this video trying to make me buy something, make me vote for someone, make me believe in some idea? Is it just like a fun video that is, I don't know, we have astronaut cats, right? And that's just fun. That's not making me buy something. So maybe it's okay if it is satire and if it is just for comedy, then that's okay. But if it is trying to make you believe in a politician, or like make you buy stocks, or authenticate someone. Like all of these are cases that deepfakes are being used very frequently, and we need to really look at something, try to understand the context, try to understand why they are doing that. If it is if you have a personal connection with that person, like would they behave like this in real world? Do we have a passphrase that only that person would know, but an AI system trying to mimic that person wouldn't know, etc. So these are some cases that you can try to be a little bit more insightful, a little bit more inspective, maybe, about the
Mm,
content that you are looking.
mm,
Okay, I guess I have to be skeptical about, things I see online, and I gotta, check what the contents are being used for to actually, react to whether I should be worried that it's a deepfake or I should just see it casually.
Exactly, exactly. And then there's online detectors, right? Like if there's some content that you are super unsure about and you really need to know if it is real or fake, there are many online detectors that you can check and see the results. Then based on that result, you can make your decision. These detectors are usually based on different things. So if it is just trained on raw data versus if it is using some um, intermediary signals like biological signals, etc., that's like different because it won't be conforming to the artifacts of the raw data. Like we, as you said in the introduction, we built Spike Catcher, which is actually looking at the blood flow on the skin and trying to understand if the blood flow is consistent and coherent everywhere on your face, spatially, temporally, and spectrally. Then it says, okay, this looks real, because for fakes have many hearts, not just one heart, so it's not consistent at all on the face in the skin. So that's one of the detectors that we built. We have many others looking at motion, looking at gaze direction, looking at different things.
So you've worked on detecting and also creating generative models, yeah? So does playing both sides has it ever made you feel like you're a superhero and at the same time a villain?
Neither. We are just trying to use AI for better things, for more human centric things, for more responsible things while still being aligned to our human values, not just for automation and not worrying about the rest. The generative models that we built are mostly either they are um, adversarial attacks that are trying to make the generative models break when they are not doing the correct thing. For example, we have My Art, My Choice. That's the name of the paper. In My Art, My Choice, we learn to generate a protected version of an art piece, of a photograph, of something that is visual. And when you give the protected version of that content to a generative model, to stable diffusion, to flux, whatever, it actually breaks. The output doesn't look like the input at all. The output doesn't have the same style, doesn't have the same content, etc. So that's a generative model. My art, my choice is itself is a generative model, but it's be using it for good. Um, we have um, we have Mixin. That's like an old paper, but it's still very proving itself to be useful. So Mixin, which is actually the short for mixed synthesis, um, makes a little bit more selective collages of faces. So it takes, let's say, my cheeks, your eyes, let's say, Angelina Jolie's mouth, and puts it all together and makes a new person from that combination. And it was at that time, this is not a diffusion model, so it is an old paper, but it's still like sparking some interest about how we can actually mix and match people uh, to do privacy preservation, because you at the end of the result doesn't look like any of us. If you look at locally, yes, it will still be my cheeks or your eyes, but if you look the whole of it, it won't be any of us in particular. So it's a new person. So yeah, these approaches exist for um, providing different tasks, different motivations for different using different models.
Wow, wow, mixed scene. That's an interesting one. I think I would go check that out. I mean, but the way you explain it for a generative model to have the feature of several persons but still be nobody, I mean, that sounds really cool. Really cool. I also like how you use Angelina Jolie as your example there. I mean, I love Angelina Jolie, so you must be a fan to also use that too.
I don't. Yeah, it's just like I don't know. Like most of the deepfakes use like Angelina Jolie, Tom Cruise, etc. So
Oh,
that's
wow.
like why it came to my mind.
Oh, I see, I see. So, Dr. Demir, so tell us what's the weirdest or most creative application of deepfake that you've seen so far? I mean, whether good or bad.
Hmm. Um, they have been used for different scams and frauds and phishing attempts. So, of course, these are not creative applications. These are like pure bad applications. Um, Let me see. This is a very old application, but I think it's a very creative one. So, um, Dali Museum, Salvador Dali, um, created one of the very first deepfakes. They actually took a photo of like a very old image, black and white, actually sepia image of Dali, and make that photo talk and interact in a very large display in Dali Museum, as if Dali is still alive. And as far as I know, that deepfake is done with all the consents from the Dali Museum, Dali family, like everyone that is actually have a right to say in his likeness actually was involved in creating that deepfake. So it was a done correct way, like of deepfake. And then when the children or adults go to Dali Museum, they can have that little interaction talking with him. And he's like, I am Salvador Dali. Can you believe it
Wow.
or not? Like there is that video. You can
Yeah.
look it up online. It's on YouTube. Yeah. So
Yeah, I
it's, I
sure
think,
will.
very creative application.
Indeed, indeed. That's a really creative application. Yeah. Yeah. So, I'd like to know, what are some biological signals that you can use to identify deepfake? I mean, without fake catcher technologies, just by yourself.
hmm So, fake catcher, as I mentioned a few minutes ago, looks at the blood flow. So when your heart pumps blood, it goes to your veins, and your veins change color. That color change is not visible to our bare eyes, but computationally, we can actually measure those color changes on the skin, and that's called photofluorescence, PPG for short.
Hmm.
So we use those PPG signals from very small areas on the face. And if it's a real video, all signals should look like that sinusoidal, that is like have a shape that is constant. My heart rate may be changing, so the sinusoidal may change like a heart monitor, but it still has these properties of being a heart rate, representative of a heart rate. And getting it from many places, they need to match, they need to agree, they need to be consistent on spatially, temporally, and spectrally with each other. Now, if it's a fake video, these signals don't look like sinusoidals. Those signals do not match with each other. It's as if you have more than one heart. So fake catcher is based on that. Then we looked at other signals like gazes. So when us humans look at a point, we shoot rays from our eyes, and those rays converge on a 3D point. But for fake gazes, the gaze are not planar, or they are like googly eyes. They can even be divergent. So we actually get these the gaze vectors, the 3D gaze points, 2D gaze points, the symmetry, color, and shape of the eye and iris and pupil. And we put all of them together in a gaze signature. And on that gaze signature, we run a network so that we can actually find out whether it's a real or a fake video. Another one is motion. So it doesn't need to be like that big motion. I am super animated. I move a lot, but it doesn't need to be that big motion. When I'm smiling, or when I'm like holding my eyebrows, or when I'm like just blinking, my muscles have this like submuscular motion, and that motion is represented very nicely in motion magnification approaches. So deep motion magnification or phase-based motion magnification really reflects these submuscular motions. So we have this dual representation of motion from those magnifiers, so that we can actually find out like if the motion is real, if the motion is consistent or not. So that's another one. Then we actually took that motion representation and combined it with audio. So when I actually move my head, there's actually some coherence with the change in my voice and my motion, and that's actually capturable in a deep representation. So that's the multimodal version that we look whether the visual and sound is actually matching each other. These are some of the approaches that we built over the past 5-6 years, maybe, and many others are coming. Maybe lastly, so detection and biological signals are important for interpretability, for understanding where your decision is coming from, but also representing that decision in a um, interpretable and explainable way is very important. So we don't only make those detectors and throw it and say, okay, these detectors are there, look at the results. We actually look at their uncertainty. How uncertain are the results? What are the confidence intervals? We look at their explainability. Can we actually find out if it is a fake? Like, where is the fakeness? Can we localize the fakeness? Can we use more biological signals so that the result is more interpretable, etc.? So we are trying to be a little bit more human centric in our detection approach, so that we don't just give you a result, say 90% fake. We are trying to also answer why it is 90% fake, where it is 90% fake, how it is 90% fake. Again, like biological signals gives like one answer about like, okay, according to the heart rate it is fake, according to the gazes it's fake, according to the motion it's fake. Or we give these saliency maps, and then like, okay, like the eye area looks very fake according to the prediction. Or we usually see these like mouth things. If it's a lip sync video, for example, it's like very, very red on the explainability map that the lips are fake, basically. So there are many different ways that we show why it's fake.
Yeah, interesting. So, Dr. Demir, at Facebook, you created generative street addresses from satellite imagery. Yeah, could you explain how this technology works?
Absolutely. That was one of the most impactful uh, projects that I worked on, I guess. um, so generative street addresses, in a nutshell, looks at a satellite image, applies some deep learning to find the road pixels on the satellite image. Then it vectorizes those road pixels to represent the roads and road segments. Then we cluster those road segments to find the dense areas, dense neighborhoods that kind of mimic our how our cities are shaped, basically, how our postal codes are shaped a little bit. Then from within these regions, we order the roads. We first find the directionality of the roads, then order the roads based on their closeness to the downtown. And then we name them in a procedural way to represent the kind of real world looking like street address. So at the end, sorry, and then along a road, we actually put this distance fields so that you have your house number. So if it's like directly on the street, it is A. If it's a little bit further from the street, it's B, etc. And then along the road, from the start of the road to the end of the road, you have your house number, let's say like 10, 20, 30, whatever, going down the road, or like 10, 12, 14 going down the road. So at the end, your generated house number becomes like, let's say, 12A WA 20 dot Seattle, Washington, let's say. So the region shows how far you are from the downtown in a central in a centric way. Um, then that W means west of the downtown. A means a little bit further from the downtown. So WA region is that. Then WA 10 means like 10th road on the in that region, and 12A means the 12th house, a distance from the 12th house on the road, a distance from the road. So that's Generative street addresses, and the reason we needed to do something like that is actually at that time 70% of the world was not mapped. So there's this huge paragraph that goes as if your address, right? It's like it says, I don't know, see the market, take the first right from the market, the second street on the left, etc. So these like human written addresses are your postal address, and it is used for your deliveries. It's used for, I don't know, your electricity. It's used for your voting. Like it's used for everything.
Yeah, yeah.
So we said we can do something systematically in this case, and the best part is on paper as a published work looks great, right? Like it solves everything. It's like, oh, should like good for Facebook and MIT to do that, right? But in reality, we actually deployed it in a pilot area in a developing country, where the actual delivery people used the addresses coming from our system, and including the training time, including how they learn how these addresses work, there was 21 minutes less on average about how the deliveries are made. And this is like very revolutionary for that study to actually have something that is concrete. And that's not even counting for the lost packages or like not found addresses or unifying the addresses to represent someone, etc. It's like it really brought physical visibility and physical consistency about how you are placed in the world, basically.
Interesting. Wow, that's such a wonderful innovation. I mean, growing up in Nigeria, I once lived in the developing community. So, there were times where I needed to fill my address for certain purposes, and I would be like, my house doesn't have an address yet. And it was really a complication, even at the time where I had to do some verifications that involved me submitting a utility bill that has to contain my house address. I had issues with it, and it took a while before we're able to then establish the address for my house before I was able to solve those issues. So yeah, I think that's a really, really impactful project there, Mr. Demir.
Absolutely, absolutely. Yeah. Thank you for hearing about the need for it. Yes. It was also very impactful in another way. So we partnered with OpenStreetMap, and they were at that time helping all the disaster response teams for hurricanes, floods, fires, etc. Because when those things happen in a non-mapped area, they have no way to actually know how to go there, where to go there from, etc. So because we can create these streets and addresses very fast, very automatically, whenever there's a disaster, OSM team actually comes to us, we create the map, we give it to them, and they actually distribute it to the disaster response team, and they can actually immediately use the maps that we say, and okay, like the fire is at like the, let's say from um, 10A NA to, let's say, 15B NB regions, and they can actually map it, and they can reach out much faster when they use those addresses in a non-mapped part of the world.
Great, great, great. That's a really cool innovation, yeah. So, moving on, I'd like to ask, with the advent of AI and computer 3D visions, what will future engineers need to learn computer-aided designs, that's a CAD, from scratch, or will they just have to talk to an AI to generate designs? What do you think?
Mm, I think right now, more than ever, we need very good engineers to pinpoint all the incorrect things, all the faults, all the errors that are coming from AI generated code. Because having a very simple prototype is easy. Like, yes, AI can do that. A cloud code can now create like a very simple prototype of something, but debugging that, finding it ready for scaling, making it ready for all the edge cases, making it secure for all the attacks, etc. For these, we need like better than ever engineers, because when Claude creates this like super big code that is many many pages with all the detailed documentation and stuff, you still need to go and debug why it doesn't work for this edge case, etc. And if you are not a good engineer, you may think that, well, if I write it from scratch, it will take less time for me to debug, etc. It will be with less functionality, but I will write it from scratch. But if you have the best engineer, that they can actually look at the code, pinpoint the point, pinpoint the shortcoming, pinpoint the limitation very nicely, and then they can coexist and like co-create with AI in a very very efficient way. So no, I think it won't be that like, okay, they will do AI will do everything and engineers won't do nothing. No, it's now we need even a more critical eye to see those mistakes.
Wow, that's a really, really great perspective. So, AI for volumetric filming sounds so sci-fi. So, could you break it down to me like we are sitting at a bar?
Of course. So volumetric filmmaking is basically doing 3D movies, 3D shorts, 3D games, with 3D capture, not doing it in post. So Intel Studios, which was the world's largest volumetric capture stage, was this huge dome, like half sphere, that had 108K cameras in on the dome, that is capturing the 3D space, capturing 10,000 square foot of space simultaneously. So what do you do with that much data, right? Like it was 270 gigabyte of data per second. 270
Wow,
gigabyte per second of
wow.
data coming. Just imagine. Yeah. So how do you store it? Like there are so many research questions there, but at the end of it, we take all of those videos and create 3D content, and then that 3D content can be viewed, can from everywhere, can be edited, can be our any amazing animators adding VFX artists adding so many things, visual effects on them. Directors can look at the scene from wherever they want. They can put the cameras for 3D render uh, to from anywhere they want. One funny way to explain that was, I think one of the very first things that is shot in the studio was a Western movie, Western short. So they actually brought real horses to run in the studio to capture the horses and like the Western scene. And in the post, after it is created in 3D, um, they actually put the camera in the eyes of the horse, so you can actually watch the world from the eye of the horse,
Perspective of the
how it is
horse.
going.
Oh, great.
So when we say you can put the camera anywhere, literally you can put the camera everywhere, and that's done. Of course, like we don't put cameras in the eye of the horse when we are shooting, but we are doing it when we had a 3D movie. Then these 3D movies are premiered in Venice Film Festival, Tribeca Film Festival. We created some AR series for phones. We created some location-based entertainment pieces in Korea, in other places. We get to see real K-pop artists come to our stage and do their K-pop dance for their music video, and then we captured them in 3D so that it is shown everywhere. One of the very early applications was actually the Grease musical. So for the anniversary, I don't remember which how many years, but for the many years anniversary of Grease, the original choreographer and dancer, not original dancer, but original choreographer came to the studio and they actually reshoot it in 3D. So you can actually go and dance with the musical Grease. So yeah, there has been many applications. Unfortunately, the studio got shut down during COVID, but it was a really, really futuristic place.
Yeah, yeah. Sounds really, really interesting from what you just explained so far. So, I'd like to ask, what does the future holds for the filmmaking industry? I mean, do you think AI will someday replace traditional filmmaking, or just give me your opinion on this.
Mhm. Um, that is still, I think, becoming a controversial topic a little bit. I don't think there is a black or white answer. It won't be all AI. It won't be all humans, and some tools will be adapted. Some tools won't be adapted. I think I we should all believe that there will always be a human element in it, because why would people watch something that is completely computer generated? It will be repetitive. It will not have the the emotional components. um, but the way that the movies are done will be changed, and that has been the case. Like, the more automation that we have, the more AI applications that we have, the more freedom for creativity using those tools that we had, it has been transforming. It hasn't been like uh, we are not using the same tools from maybe 10 years, 20 years ago, right? So, but it won't be as like such a sudden change that, okay, now everything is AI, you know. And the very important thing that we are also working on, but many other people are also working on, is how can we make those generative models more controllable, more editable, more compositional, so that there is the bridge between traditional tools and AI based tools are um, we bridge those two extents, right? Like, we try to close the gap between the traditional workflows and AI-based workflows. Because if you don't have control, if you don't have compositionality, etc., then all of these tools are creating amazing visuals without you being able to edit them. So I think it will be a transformation, but it won't be like a very sudden thing that many people are left behind, etc. I think it's like step by step. When something is working, the industry will adopt it.
Great, great. That's interesting. So, let's uh shift back to academia a bit. So, Dr. Demir, you completed your PhD. Yeah, so I'd like to ask, what advice do you have for students who are looking forward to going for postgraduate studies in STEM-related fields?
Of course. So one thing that never failed me is always following my curiosity. If some problem makes me curious, I try to learn about it. I try to find that solution space to that problem. Or if that domain is very making me curious about new things, new research dimensions, new applications, new use cases, then I try to say, oh, well, what happens if I try this? What happens if I try that, etc. So this has been my motto, that always, always, always have your curiosity wherever you are in your life. Be curious, ask questions, try to get a little bit deeper on that topic, try to get your hands dirty on that topic. I'm not saying like build, 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 but always experiment. Always experiment. What happens if I give this value? What happens if I implement it this way? They say that it is like this, but what is the actual theoretical formulation for that? Is it just like a practical implementation, or can I find a different theoretical representation for that? So for anyone in STEM field, if you are curious, if you are asking questions, if you are doing research, then I think success will follow.
That's a great advice. I myself would hold on to. I mean, looking forward to PhD, postgraduate studies. Yeah. So, always experiment and hold on to your curiosity. I think I would write that at a sticky note and hang it on my wall, so I get to see it every day. Okay, so Dr. Demir, what advice do you have to give to females in STEM that are following your footsteps?
Mhm. Um, so there are some, maybe sometimes for some people, and maybe that's like it's more common for females, but it can be everyone. Um, we need more tangible evidence before we take action. So if we, let's say we are in a research meeting, right? And I have this, and someone is talking about a problem, and I have this paper in my mind that, oh yeah, that was that paper that actually solves that problem. So usually, a woman first Google the paper, remember the exact name of the paper, exact authors of the paper, venue of the paper, and then talk and say that, oh, there's a paper that actually solves that problem. um, Men or people that may not be thinking in a super multidimensional way, um, actually just talk without any evidence, saying that there's a paper that does that. I don't remember the paper, but there's a paper. I think it was from MIT or Stanford. I don't remember, but there's a paper that does that. So what is the difference, right? The first one is super much more informative. It's giving you the title, it's giving you the venue, everything, but it's coming maybe 30 minutes after, or it maybe it's coming after the meeting. Maybe it's coming after the context pass. Maybe two more people talked after that, and they actually are coming behind. Whereas the other person reacted immediately, saying that there's a paper like that, without that much information, but there is a follow-up opportunity that they can actually follow up, right? So my advice is you don't need that much evidence to talk. You don't need backup to talk. Your voice has as much value as anyone in that room. If you're in a room, your voice is as audible as anyone in that room. Whether it is your advisor, whether it is seniors, whether it is investors, whether it is like super scientific professors that are doing marvelous things. If you are in a room, your voice holds as much value as theirs. So do not hesitate to talk. Do not hesitate to contribute. Do not hesitate to share your idea. And always be like very, um, if you are doing a PhD, if you are doing a research in your topic, you are expert on that topic. You are more than expert, like you are an expert more than other people in that topic. And always like trust your words, trust your voice a little bit more. That would be my main advice, because there are so many lost opportunities. If we can include people in conversations more, we can have more voices, more perspectives, then that actually really, really flourishes the teams, flourishes the ideas, flourishes the projects.
That's a wonderful, wonderful piece of advice. So, I have one more question for you. So I personally like to save this one for the last to ask every guest I interview here on the Feria TechCast. So, Dr. Demir, tell us, what does innovation mean to you and how it relates to your field?
Um, I think innovation is building what is not built before. So whatever is beyond whatever was beyond imagination, if a new, a novel contribution is solving that task, is bringing that um, new solution to for that task, then I think that's innovation.
Hmm. So tell us how it relates to your field. I mean, in proceduralization, in deepfakes, in generative street addresses, 3D visions, and even volumetric filmmaking.
Of course. So, for example, if we look at deepfake detection, defect detection, it's not like being able to detect fakes is no longer, I think, an innovation because there are so many things that are used for that. But doing it in a novel way, right? Like fake catcher, like looking at the blood flow, which is a completely irrelevant things to deep fakes, and then using it in this domain is actually very nice, uh, multidisciplinary innovation. Or finding a novel solution. So we are working in 3D, right? So novel solution for making, let's say, Gaussian splatting in a very editable way. So just imagine that you are editing Gaussian splats as if you are editing the meshes in a traditional way, right? So that would be a very nice innovation that hasn't been done in a very comprehensive way yet. So these are some like very nice innovations that are done or to be done. And so I think um, innovation starts with curiosity, as we just talked about, right? So curiosity pushes you to ask questions, to get deeper, and then you bring innovation, which is actually solutions or answers to those questions. So I think curiosity and innovation goes really nicely hand in hand.
All right. So, Dr. Demir, what's your call to action for our audience?
Mhm. So first of all, don't believe everything you see online. Always have that critical eye about why this content is trying to make me do something. If it is just making you laugh, just laugh. If it is making you learn, just learn. But if it is making you do some action, then think whether it is real or fake. Then if you have um, more questions on content authenticity or content provenance or generative AI or how to protect your own content in the age of generative AI, you can always reach out to me with your questions, with your business questions, with your student questions, with your project questions, with your curiosity questions, from Ilke at ilke.ai. So ILKE at ilke.ai. And yeah, I think like trying to build this safe and trusted online digital future is the duty of all of us. So trying to not believe deepfakes, trying to not uh, spread deepfakes or misinformation, not using generative AI models for nefarious things, etc., is all of our duty, not just mine.
Interesting, interesting, interesting. So, Dr. Demir, it was nice having you on the show today, and I'm really honored to host you on the Feria Techcast.
Likewise, thank you for hosting me, and I hope uh, all your online future would be safe.
Yeah, yeah.